Hello students. Today we will solve few problems in semiconducting materials. Okay, there were few representations from your class asking for problems to be solved through video lectures. So I am doing this video for you. I am Dr.R.Priya, Professor of Physics, RMD Engineering College. These are the problems given in your digital content as assignment. I am not going to solve all the problems. I will be solving only the similar type of problems so that the other things can be done by yourself. Also, I have changed few of the data. I am not doing exactly same as given in your assignment because assignment is your work to be done by you. Okay. So this is a continuation of the previous slide. So let us read the question. The band gap of an alloy semiconductor GaAsP is 1.98 electron volt. Calculate the wavelength of radiation that is emitted when electrons and holes recombine directly. So this is given from semiconductor laser. So you know the band gap calculation. Eg is equal to h nu, which is equal to hc by lambda. Now, what is given in the problem is Eg is equal to 1.98 electron volt. What is asked in the problem? Lambda is asked in the problem. So, I know C value, it is C 3 into 10 power 8. H also I know. So, I have to now calculate lambda, for which I have to rewrite the formula. So let us rewrite the formula. Lambda is equal to hc by Eg. Now I have to substitute the values. Before substituting, we have to see whether any conversion is required. So Eg, energy will normally be used as joules, not as electron volts. So it has to be converted. So it requires conversion. So how to do that? 1.98 into 1.6 into 10 power minus 19 joules. Okay, so now rest of the values you know. So you substitute 6.6 into 10 power minus 34 into 3 into 10 power 8 whole divided by 1.98 into 1.6 into 10 power minus 19. So use the calculator to find the value. I am also using the calculator. Meanwhile, you also use the calculator to find the value. When you are feeding the data in the calculator, don't try to feed all the terms at a time. You can go step by step. Your ultimate target is only to get the correct answer, not do everything in one shot. So I think you have got the answer. The answer is 6.25 into 10 power minus 7 meter, or I can write this as 6250 Armstrong, which is in the visible range. So this is the answer. So similar problem, one more problem is given in the assignment which you can solve by yourself. You don't need my help. Based on this learning, you can do it. We will go to the next problem now. Let us read the problem. The electrical conductivity of germanium at 20 degrees C is 250 mho per meter, and at 100 degrees C it is 1100 mho per meter. What is its band gap? So that is the question. So we know the equation for connecting the band gap and the conductivity. So let us start with that. You have to see in this, there are two temperatures and two conductivities given, but for the same material, which means the band gap will not change. So you only have to handle the two equations. You have to write two equations and simplify it in such a way that you are able to bring band gap. Okay, so let us first write the equation. Before that, let us write the given terms. So I assume for first temperature 20, the value of electrical conductivity to be represented as sigma 1. So sigma 1 is equal to 250 mho per meter. Ohm power minus 1 is nothing but mho per meter. Okay, T1 is equal to 20 degrees C. Then sigma 2 is equal to 1100 mho per meter. T2 is equal to 100 degrees C. Now I can convert this because I have to convert because it is in degrees C. So 200 plus 273, which is equal to 293 Kelvin. Similarly, this one 100 plus 273 is equal to 373 Kelvin. Now let us write the equation. Similarly for sigma 1 separately, sigma 2 separately. So sigma 1 is equal to C exponential minus Eg divided by 2 kB T1. Similarly, sigma 2 is equal to C exponential minus Eg divided by 2 kB T2. So I want now Eg. So what I can do is I can take the ratio. Okay. So sigma 1 by sigma 2. C exponential minus Eg divided by 2 kB T1 whole divided by C exponential minus Eg by 2 kB T2. So C and C getting cancelled. So both are exponential. So their powers, when it comes to the numerator, it will become reverse. Okay, so exponential minus Eg divided by 2 kB T1 minus, this is already a minus is there, so it will become plus Eg divided by 2 kB T2. So what can I write now? Exponential, I will take Eg divided by 2 kB commonly, then write 1 by T2 minus 1 by T1. You understand? This is minus 1 by T1, here plus 1 by T2. So I am ordering it properly. That's all. Okay, so that is my sigma 1 by sigma 2. So what I want is Eg, which is present inside the exponential. So what should I do? I have to take ln. Okay, taking ln on both sides. So ln sigma 1 by sigma 2 is equal to, ln and exponential gets cancelled. I will get Eg divided by 2 kB into 1 by T2 minus 1 by T1. Okay, I will continue here. You have the value for sigma 1, sigma 2, T1, T2, everything. So first let us rewrite the expression for Eg. Eg is equal to 2 kB ln sigma 1 by sigma 2, and then the whole term will come to the denominator. So 1 divided by 1 by T2 minus 1 by T1. Now you substitute all the values, handle the calculator correctly. You should get the answer as 0.204 electron volts. That is, initially you will get in terms of joules, which has to be divided by 1.6 into 10 power minus 19. Only then I will get electron volts. In the previous problem, it was reverse. What we had was electron volts. So to convert that into joules, we multiplied by 1.6 into 10 power minus 19. Here what we are going to get will be in terms of joules and we are converting it in terms of electron volts as the final answer. So it has to be divided. Okay. So this will be the answer. You can check it. So we will go to the next problem. So let us read this problem. Calculate the conductivity of germanium at 200 degrees C. Given that at 200 degrees C, Ni is equal to 2.3 into 10 power 16 meter power minus 3. Mu E is equal to so much and mu H is equal to so much. So first let us write the formula for this and check whether all the data is given in the problem or not. Now if you look at the problem, you can identify that it is basically representing intrinsic semiconductor because intrinsic carrier concentration is given. Also one more hint is mobility of both electrons and holes are given. Okay, so let us write the equation. Sigma I is equal to Ni E into mu E plus mu H. So Ni, mu E, mu H, everything is given. E is a constant value. So you have all the data here. So now substitute. So 2.3 into 10 power 16. E is 1.6 into 10 power minus 19. Mu E is 0.364 plus 0.19. Now I am also using calculator to find out the answer. You also do along with me. So I will handle the data present inside the braces first. So 0.364 plus 0.19 is 0.554. Now I multiply with the rest of the terms into 1.6 into 10 power minus 19 into 2.3 into 10 power minus 16 plus 16. So what answer do I get? I get 2.04 into 10 power minus 3 mho per meter. That is my sigma I. So the problem is so simple, no? Usually this kind of problems only will come most of the times. Your challenge will be only two things. One is to identify the topic from which it is given. Okay, so the conductivity means you are having an expression for conducting materials, then for intrinsic, then for p-type, then for n-type. So which is asked, that has to be found out. Okay, and then handling the units, whether it requires any conversion or not, whether it is in the appropriate MKS system or not, that has to be checked and suitable conversion has to be given. Otherwise it will be mostly a substitutional type only. Okay, so let us go for the next problem. So another similar problem with a little difference. Let us read the problem. The electron and hole mobilities are 0.17 and 0.035 meters square per volt per second respectively at room temperature. If the carrier concentration is 1.1 into 10 power minus 16 meter power minus 3, calculate the resistivity of silicon at room temperature. Okay, so here it is resistivity asked. Previously the conductivity was asked. Okay, so you know the connection between resistivity and conductivity. So conductivity is reciprocal of resistivity or resistivity is reciprocal of conductivity. So now we know an equation for conductivity. So we will find out the conductivity first and then reciprocate it to find out the resistivity. That is what is asked in the problem. So previously we had all the notations also given in the problem itself. So we did not write the given statement, but now it is only given as hole mobility, electron mobility without giving any notation. So we have to give the given data. Given data, that is electron mobility mu E is equal to 0.17 meter square per volt per seconds. Mu H is equal to 0.035 meter square per volt per second. Okay. then Ni is equal to 1.1 into 10 power 16 meter power minus 3. So now write the equation. We know sigma I is equal to Ni E into mu E plus mu H. So 1.1 into 10 power 16 into 1.9 into 10 power minus 19 within bracket 0.17 plus 0.035. So I am also doing along with you in the calculator, so please do. So let us start with the terms given in the bracket. 0.17 plus 0.035, 0.205 multiplied by 1.6 into 10 power minus 19 into 1.1 into 10 power 16. So I will get 3.6 into 10 power minus 4 more power meter. See here for electronic charge 1.9 I have given. So please change it. It is 1.6. When I calculated, I did it correctly, but when I have written, I have made it a small mistake. Okay. So this is conductivity. Now what is asked in the problem is resistivity. What is the notation for resistivity? Rho I. Okay. So 1 by sigma I is equal to rho I. So I will write rho I is equal to whatever I have obtained previously. I will just reciprocate it and write. So I'm getting 2.77 into 10 power 3 ohm meter. Okay, unit also reciprocal of it. So mho becomes ohm, per meter becomes into meter. Okay, so this is the answer. So with this we complete this problem. So I am stopping the problems with this, and I will continue with one more video on problems itself. So please do as many problems as possible. Okay, only then you will be confident when you are writing in the examination. Okay, we will do still challenging problems in the next video. Okay, thank you students. Thank you.